Hey AP. In this video, I want to walk you through an example of how we can take a program that we've worked on, not necessarily in the past, but something that inspired us, that we started to write the code for. We don't necessarily have all the formal elements of it, like functions or classes. We've just decided to write some code that does something cool. And we're going to look at how we can take an example of that kind of code and turn it into code that meets the requirements for the create task. This example is posted on Google Classroom. You're welcome to experiment with it on your own. One note that I want to give you is the final code is in this better.py file, which we're going to run shortly. Or excuse me, not run, but look at shortly. However, if you go to run the code, it's going to be running main every time. So if you wanted to see how exactly the better code works, just remove everything from main and copy and paste over what's in better.py. So let's look at what we have here. This program uses the Beautiful Soup library in order to pull the HTML from a wiki page or Wikipedia page, and then it gets all the paragraphs on the page. From all those paragraphs, it finds the first paragraph and it will print it out, or it will, it will also find all of the links on the page and print those out. Let's look at an example of it running. So I'll run the code over here. It'll install the dependencies, which is basically Beautiful Soup and requests. And then from here, I will type in something that I want to know about. For example, like a weasel. Okay. So on this, or in this output, the thing we see mostly is all of the links, because there are so many links on a Wikipedia page. And perhaps if we scroll to the top here, we'll be able to see the first paragraph, and we're not. So in order to alleviate that problem, we'll just come over here. We'll comment out the portion that gets the links through the find all method and the A argument. And we'll run the code again. Clear our console. Try one more time. Okay, weasel. There we go. And that's the first paragraph from the weasel Wikipedia page. And we can confirm that right now if we like. There you go. So it says weasels are mammals of the genus Mustela, of the family Mustelidae. What an interesting name for a family of animals. But look at that cute little weasel over there. Okay, so there you go. That's an example of some code that you could write on your own with a little bit of research and pull data from web pages, which is something that we did in your sophomore year, perhaps your junior year if you're a senior. And so the question is, how can I take this code and turn it into something that meets the requirements of the create task? Because right now it does not. It contains several elements that are required by the create task. For example, this is a collection. You would need to identify that specifically with your response, because it's not clear that this is a collection, but all paragraphs actually is a result set, which behaves quite a bit like a list. It's a Beautiful Soup object. And then it does contain some selection. And it does contain iteration as well. However, nothing is organized into a function. And so in order to make this program meet the requirements, I'm going to take my existing ideas, improve upon them a little bit, and organize my code in functions. I'll also make a clearer list when I show you this example. So here we have the better example. The first thing that you'll probably notice is that there is a function right in front of you, and that function is called find and display element. It takes an argument, or excuse me, it has a parameter called element tag, and that argument, which we can expect, is going to be either a P or an A. It could be something else if we can extended this function to work in a more complex manner. But for now, it just takes that. Notice I've used a docstring. You should probably use docstrings as well. It will help you create a concise written response. And it will help the reader understand what your code does. So that's a bonus. Okay, and then we can look at the slightly changed behavior of our code. So element tag is our parameter. So we'll say that if that element tag is a P, then we're going to find all of the element tag. and then we will return, not print, the first paragraph based on this method of selection. So this covers the selection and sequence portion of the requirements. And now that we've added, or when we do add, this elif, where we're looking for the tag of A, we're going to add the parameter changing the behavior of the code. Originally, we just had a script where it said, okay, I'm going to find both the paragraphs and the links. And we took that script and we made it into a function which changes its behavior based on the nature of the element tag. Again, although all links and all paragraphs are both lists, because well, they're not lists, they're collections, I should say, because Beautiful Soup has these as result sets. As you can see, if we type in the type of all paragraphs over here, actually this won't be available because it's in a function. Whoops. If we were to type in all paragraphs, in fact, if we were to go back to, let's just run our code again real quick and I'll show you. So there's no mystery behind this. Okay, we'll type in Weasel again. Okay, and we'll say type all paragraphs. Okay, it tells us it's a result set. However, because all paragraphs is indexed, we can do things like this. And so it is a collection type. However, as we mentioned before, AP readers are not necessarily the most experienced programmers. In fact, if we were to consider AP readers as a whole, there's only going to be 1 or 2 of them there that likely know what the Beautiful Soup library is, much less a result set. So with that in mind, even though we have some collections here, we're going to make a very clear example of a collection via a list for our reader to see. So when we get the A tags through all links, what we're going to do is we're going to create a list which is only the text of the link. So what we do is we create an empty list, that's very clear here, and then for every link in this list of all links, we're simply going to append the href, or the actual web link of that link, and then append it to link text list, and that is what we will end up returning. In your written responses, you would do things like identifying this list as the list you're talking about. A way that this manages complexity is that were it not for this iteration, you would have to go through and, or excuse me, were it not for the iteration and the list, you would have to go through and somehow provide a variable for the hundreds, if not thousands in some case, links on a Wikipedia page. So that's how this manages complexity. If you wanted to take this a step further and make this a more interesting program, you could look for links that only have certain things. For example, if you wanted to only identify links which include, let's see if I can find an example live here without any preparation. Okay, so here are what I believe are external links. Yes, so notice that all of these that say A class equals external text, these are links that exist outside of Wikipedia. So they're the sources for the information on Wikipedia. That might be an interesting thing to know, is what links are external to Wikipedia on this page. Another one might be talking about what are all the categories in which weasels exist. So for example, weasels exist in several wiki categories, including obviously weasels, mammals of Asia, mammals of Europe, taxa named by Carl Linnaeus. That's pretty interesting. This is actually one of the more fascinating parts of Wikipedia that I think you could do some data science around, is this idea of categories. So it's almost like if you guys have ever heard of the game 6 Degrees of Kevin Bacon, you probably haven't, but if you Google it, it reminds me of that in some ways. Okay, so hopefully this gives you some clarity on how you can take whatever code you end up writing that is interesting to you and kind of massage it, for lack of a better term, into code that meets the create task requirements. This would, if I explained this code well, it would certainly meet all the requirements of the create task and we would get a maximum score. Thanks for watching, and I look forward to seeing you soon.